Welcome to Code to Scale. Today let's discuss about Singleton Pattern, why it's important. So the agenda for this video is to kind of implement Singleton Pattern using any language of your preference. For the scope of this video, I'll be using Golang because that's my preferred language. I love it a lot. And we'll kind of go into a little deep wherein we'll see whatever we implement, is it thread safe, is it not thread safe? So before we kind of jump into implementing Singleton Pattern, let's kind of understand why Singleton Pattern is used, right? So assume that you have a service and the service talks to your database via some database library, and this is your end database, right? Now consider a scenario where you have very high traffic. Once you have high traffic, right, each request that your service gets, because classes are implemented in such a way that each request is going to create a new database object. Now, so creating a database object is an extremely resource intensive process, right? And we don't want to do it over and over again. But if we do it over and over again, what can happen is your service can eventually go down. Imagine, let's say you have like 1,000 requests per second coming in for your service. Now your service is serving 1,000 requests per second. For each request, you're creating a database object. Now it's extremely resource intensive for the service as well as the database to handle all that many connections, right? Instead, like the same thing to do would be to ensure that, okay, whatever request is coming, you use the same database object. And Singleton is one way to ensure that no matter how many requests you get, you're using the same shared resource, which is the same shared database object that is created, right? So that is the whole point of Singleton in a brief gist. You never create as many database objects as a number of requests you're getting, right? That's like the kind of gist that we're going after. So let's implement the Singleton pattern. Let's see if it works or not. And then once it works, if it works, then we'll see if it is thread safe or not thread safe or whatever, right? So let's start. Okay. I'll implement this in Go. So we have a package main. Let's have a database object. Let's see, this is a struct. It contains a database instance ID. And let's say this is a string, right? Cool. Now what we want to do is we'll use something called as a sync package. And sync will ensure thread safety, and we'll see how it does that as well. So I'll declare some global variables, database, maybe instance, and this is going to be a pointer to database object. So this is what will store the actual database object, and we only want to manage this database instance, right? And we also want once, sync.Once. There are of course other ways to do it. You can implement your own sort of locking mechanism, but I wanted to kind of deep dive into this, so I'll show you how this internally is implementing some sort of locking mechanism, right? Okay, so now we have defined our database object, which contains database instance ID. It can also contain your database, or let's say a table name. No, not table name, actually database name. That can also be a string. It can also contain something like I don't know, database IP. That also this is not as per Go formatting, so yeah, string. Cool. Okay, now we want a method or some sort of getter of a database instance, and that getter should ensure that, okay, no matter how many times this method is called, it'll always return the same database instance which contains the database object. So let's implement that. So let's say get database, okay, instance, and it of course has to return the same type as this thing. So okay, this is done. Now what we want to do is we want to use our once function. Once do. Now if we simply see this, once indicates that, okay, let's go to this thing, and so yeah, so once is an object that will perform exactly one action. A once must not be copied after the first use. That we are not doing. Also, what is this do? So do calls the function if and only if do is being called for the first time for this instance. So what will happen when you call get database instance for the first time? It will call whatever we do inside this function, right? Whatever we have defined here in this function, it will call it once. After all after that first instantiation of this thing, or after the first call to this get database instance, it will not call this function ever again, right? That is what it says. If once do is called multiple times, only the first call will invoke f, which is your function, right? Makes sense? Cool. So let's set our database instance. So before that, let's maybe add some logs. I don't know if you want. Let's add logs. Okay, what has happened to my Vim? Okay. So something like maybe creating a database instance. Cool. And it is already imported packages. Nice. And once we have added logs, we can set our database instance. Because we already defined, we don't need to kind of, we can just simply use this and database object. Now what all does the database object contains? It contains an instance ID. So let's paste this. And this is going to be a string. So let's say instance 1. Now it has a database name. So let's say MyDB. It's like so cliched, no? In every tutorial video you see MyDB. Okay, and then database IP. So let's, because this is also a string, so I don't know, localhost, right? So you've created your database instance and you return, of course, that, because this is what we want to return, right? So yeah, database instance. Okay, cool. So what we have essentially done until now is we have defined a database object. We know that, okay, that object is stored in this database instance. So you have defined a getter method, which when called is responsible for returning a database object. But the tricky part is it will only do it once. No matter how many times you call it, it's always going to use the same database instance. Okay, now only thing left is to call this get instance. Cool. So let's say database instance 1. So we'll try to do it multiple times, as in try to call the get instance multiple times and see if it is the same or not, right? So let's do this, and then let's do this, and let's do a simple check. Let's do a print. Are both the instances same? Oh my god. Same or not? How can we do that? We can simply do a database instance 1 equals database instance 2, right? Okay, no squiggly lines. That's usually a good indication. So yeah, the gist of this is we have kind of created a get database instance method, and we've, maybe let's call it, I don't know, one more time, just for the sake of it, database instance 3, but then it'll throw me the error that this is not used. Maybe we'll use it sometime later, but anyways. So we've tried to call the get database instance method twice, and moment of truth, let's see if both of these are same or not. So let's run. Voila, both the instances are same or not. It is returning true. That means they are same. Awesome. Cool. So this works, right? Now let's see, because you're using Go, so there will be a lot of Go routines. You may be calling this concurrently. So is this going to be like thread safe or not? Let's kind of take a look at that as well. So let's go into do. What does do? So as mentioned earlier, right? So do calls the function f if and only if do is being called for the first time. If any subsequent times, the first call only will invoke f, even if f has a different value in each invocation. That is very interesting, right? So let's say if your function f is taking different kinds of parameters as well, the first invocation is valid. All the subsequent invocation, even with different kinds of parameters, right? Even with different values of your parameters of the function, it won't even do anything, right? So let's see, is it thread safe or not? I don't see any threads safety here. I don't see any locks. So there's something mentioned as outlined slow path to allow inlining of the fast path. I don't know what slow path and fast path is, but let's go to this do slow method. Oh, and what do you have here? You have your locks. So this is what's like beautiful about Go, right? Like it's abstraction, but eventually you'll find what you're looking for. So if we would have done it ourselves without using once.do, we would also have something similar. We would have created a lock and we would have deferred. So defer essentially is called once the function is returned, right? So your lock will be unlocked once whatever it has to do is completed. So this is going to be thread safe. It's going to be, no matter what the concurrency is, no matter what, like whatever you want to do, it's going to be thread safe. It's not going to, create dirty reads or whatever. You essentially can do things in a thread safe manner, right? So I hope this was kind of helpful. So this essentially is Singleton pattern. Whatever we did here, this is Singleton, right? Singleton pattern. Isn't it like simple, beautiful, but like so helpful? So usually what you'll have is you will have like a pool size also in your DB object, and this is going to be an integer, right? So you can define a pool size here, let's say of 100. So now what will happen is, because you've defined a pool size of 100, your database object is managing 100 connections, and all the concurrency, all that stuff is abstracted away to your database library, right? And something of this sort can happen internally. It can have different kinds of isolation levels, and by isolation levels I'm referring to specifically transactional relational databases, right? So yeah, I think this is it for this one. Hope this was helpful in some way. I am kind of trying to create a design pattern series which is like kind of relevant to everyday software engineering and a lot of other things as well, thinking of live streaming. So feel free to kind of give me your feedback, and constructive criticism is always welcome. That's it for this one, folks. Thank you. I'll see you in the next one.